The bionic eye, a cure for blindness? First, I'm going to tell you how the eye works on a basic physiological level. The eye captures and focuses light, like a camera. Here's a step-by-step explanation of how the eye works to provide you with vision. First, light rays enter the eye through the cornea, the clear, dome-shaped surface covering the front of the eye. This helps to focus light. From the cornea, the light passes through the pupil, where the iris or the coloured part of your eye regulates the amount of light that is able to pass through. From there, the light then hits the lens, a transparent structure inside the eye made of layered proteins called crystallins, which focus light rays as an inverted image onto the retina. A light-sensitive nerve layer consisting of two types of photoreceptor cells, cones and rods, that line the back of the eye and transform inverted light signals into electrical impulses that are carried by the optic nerve to the brain, which assembles the signals into a recognizable image the right way up, or our vision. So, the main blindness-causing conditions from which the bionic eye can restore sight: glaucoma, age-related macular degeneration, and retinitis pigmentosa. Glaucoma. Glaucoma is considered a group of diseases that damages the eye's optic nerve and can result in vision loss and eventual blindness. The optic nerve is a bundle of more than 1 million nerve fibers that connects the retina to the brain. Glaucoma is a condition where there is an increased intraocular eye pressure that puts a large amount of strain on the optic nerve, causing considerable damage. In the front of the eye is a space called the anterior chamber. A clear fluid flows continuously in and out of the chamber and nourishes nearby tissues, as shown in the diagram on the left. The fluid drains from the chamber at the open angle where the cornea and the iris meet. When a person has glaucoma, their intraocular eye pressure increases. This happens when either too much fluid is produced in the eye or the drainage channel's trabecular meshwork of the eye become blocked due to a closing of the angle between the cornea and the iris. Next is age-related macular degeneration, or AMD. AMD is a common eye condition and a leading cause of vision loss amongst people aged 50 and older that accounts for 50% of all cases of blindness in Australia. There are two forms of age-related macular degeneration, wet and dry. The cause of both forms of AMD can be attributed to the accumulation and inadequate clearing of waste products under the retina, which appear as drusen in an eye examination, shown in yellow. This leads to damage and thinning of the macula. The macula is made up of millions of light-sensing cells that provide sharp, central vision. It's the most sensitive part of the retina, which is located at the back of the eye. When the macula is damaged, the centre of your field of view may appear blurry, distorted, or dark, and over time the blurred area may grow larger, or you may develop blank spots in your central vision. Objects also may not appear as bright as they used to be. And retinitis pigmentosa, or RP. It's a condition where the light-sensing cells in the retina begin to deteriorate, which appears pigmentations in the retina, shown on the right. It's generally estimated the disorder affects 1 in 4,000 people worldwide. The first signs of RP usually occur in early childhood, where both eyes are typically affected. In the early stages of RP, the light-sensing cells responsible for dim light, or the rods, shown in green, gradually deteriorate. As a result, seeing at night becomes far more difficult. The loss of these rods eventually leads to a breakdown and loss of the bright light-sensing cells, or the cones, shown in red. In the late stages of RP, as these cones die, people tend to lose more and more of the visual field, developing large blank spots in their vision. So, what is this amazing physiological breakthrough that's able to restore sight? It's the bionic eye. In 2014, the first steps towards creating artificial sight began with the development of this bionic eye. It's constructed from an array of stimulating electrodes placed onto the retina, right here, and is fed signals from a digital camera. So normally, a digital camera works by converting light at each pixel in the sensor into electrical signals that report the brightness of the light. These signals are then used to generate an image on a display at the rear of the camera, where normally we would look at it with our eyes. But in a bionic eye, a camera-mounted pair of glasses is used instead, where the visual display is bypassed and electrical signals are sent from each pixel in the camera to an array of stimulating electrodes in this retinal implant. When placed into the eye of a blind patient, the electrodes stimulate the nerve cells that would normally receive input from damaged or deteriorated photoreceptor cells in a normal retina. The signals are interpreted as if they were coming from normal photoreceptors. So as a result, they send the information via the optic nerve to the brain, which in turn experiences a pattern of electrical signals that replicate those experienced in a normally functioning eye. This type of system for a bionic eye is currently in trials across the world for people suffering with retinal conditions causing blindness, such as age-related macular degeneration and retinitis pigmentosa. But what about the eye conditions that affect the optic nerve, such as glaucoma? Well, for people with a damaged optic nerve that are unable to send full-strength signals to the brain, scientists have created an implant that bypasses the damaged optic nerve completely and is placed directly into the brain, where wiring is used as an artificial optic nerve. This type of bionic eye implant is still waiting to be approved for trials. So, with the bionic eye seeing rapid advancements and successful trials globally and within Australia, you could say the future is starting to look pretty bright for blindness.